is done here, and this is part 3 of the FHANv3 design series. In the previous 2 parts, we had gone over the creation of a layout using Keyboard Layout Editor, and also how to build and develop the schematic for the actual layout. And of course, this schematic allows you to associate your components electrically, as well as, map out particular features if you need them. I'm just going to switch over on to the monitor. This is actually take 4 of the video because I've inevitably stuffed up things along the way and forgot certain things, like actually switching over to the monitor instead of leaving the board logo up while I was talking. So what we've done before, what we've seen is that we've got all of our switches, all of our diodes, all of our rows and columns. There's the processor and our assignments of the rows and columns against it. The last video I'd left off where I was going to name every one of these switches and diodes, which I've now done. As part of me having the other takes and kicking around to make sure that I got things right, I've had to use the automatic automatic annotation that KiCad does, which ended up adding a 1 on the end of these. So you'll see that for key switch 28, I've got the 1U switch and the 2U switch, and similarly for 40 and for 44. Moving forwards, we need to make this association to our components, and we would use this button here. So when we press it, it will bring up a different window to develop our association list. Now, because I've already done this, the actual window is open and it's already got stuff associated to it. Our left-hand side is our libraries for footprints. The middle is the components that require footprint association to components. And then on this side is actually the individual components within the libraries. So you'll see for keyboard parts, I've taken the diode SOD123 axial. And for key switches, I've taken the Keybs MX Alps 100, and then for the 2Us, the 2Us. So if I, on the left-hand side here, go to, say, keyboard parts, you'll see this is a list of parts in the library. And then we've got our diodes, hand wire, axial, so on and so forth. And similarly, if I go to the Keybs, there is the footprints for 1U, 12515, 1752, 225, 275, and 625. Now there is actually a Pro Micro footprint here, but I'm not actually using that one. The one that I'm using comes from SparkFun. Now SparkFun have a very extensive library, and one of the sub-libraries is actually the boards library, where you'll see these are all the various boards that SparkFun have on offer, and someone's gone through and created the KiCad for them, and that's the Pro Micro assignment there that I'm using. So all you have to do is just select the particular item and then double click on the component on this side, and it makes that association. Once you've associated everything in your list and you're satisfied with it, and it's okay to make mistakes because you can always come back to all of these processes and just move forwards again, you need to save it. So you save that footprint association, then you can get out of that, and we generate our netlist. This netlist is essentially a relationship builder. It says this component is related to this footprint and it is electrically connected to this diode. And so the netlist will start drawing what they call a rat's nest to say, hey, this has to be somehow connected to this component. And if you haven't connected it, it will give you a warning. It'll give you an issue. So we'll click on that. We'll generate the netlist. I've already generated it, but I'm going to save over the top of that. And done. From here, we need to go back over to our main menu for the project, and we will open the PCB file. This is when things start to get interesting for the purposes of creating the physical PCB. First thing that we want to do though is we want to change the grid size, and we want to change it to this particular value. And I believe this particular value is simply to match the mechanical keyboard footprint switches. Now you can go finer, you can go larger, but the step size, the snap to grid, this default setting is what is recommended by Rui Keymail's guide, and I'm more than happy to use it because it's worked fine for me. So make sure that you set these numbers there as inches for both X and Y, You're going to hit OK, and you have to make sure that up here on the user grid, it is actually set to user grid and not a preset value here on this list. And that way you'll be able to maintain the spacing that you require. So once you're ready to get down and dirty, you once again hit this net button, read netlist, and it will read the netlist and its associations, and it will dump all of the footprints for all of the components that you have. So we're going to hit read current netlist. Hopefully no errors come up, and no errors seem to have come up. We hit close, and bam, there is every single component of ours stacked on top of each other. And you can see very distinctly we've got the Pro Micro footprint. And the reason why I had to do a couple of takes was because I wasn't sure if this was the correct Pro Micro footprint. I have had a couple of different ones, and they didn't have the right pinouts to match what I was after. But if I open this up and we check against this, we will see that column 3 is in this footprint orientation here, which is 1, 2, 3, 4, 5 from the bottom, 1, 2, 3, 4, 5, which is A0. And if I go back to my schematic, our column 3 is pin 17, A0, column 3. So ensuring that we've actually got the correct lineup of the pin assignment is really important, and I believe that this is actually the correct one that I'm going to be using. So we'll run with it, and I of course will have to double check this later. In terms of designing a board, this is something that you need to be very aware of, because if the footprints aren't the same, because they're using a different version of a board, it will affect your end product, because when you put it on and you try and flash it, it's not that it won't work, but obviously your rows and columns will be different, so you have to program your pinouts in KB firmware differently. So we'll just keep going. So what you want to do now is you need to separate all your components, and this gets a little bit messy because there's a lot of components stacked on top of each other. So you can just use the M key with the cursor, and it will separate out components, because you can move them. And see all these white lines? This is the rat nest. This is the association of what these components have to contact and touch. So it says this one here, column 6, has to touch this column 6. And that's because in our mapping for our grid here, this is this 2U and this 2U, and they're both in column 6. So they should actually touch and relate to each other electrically. But because it's a bit of a pain, we're just going to turn off rat's nest so we don't have to see all these horrible white lines while we're working, and it just makes life a little bit easier. Now you'll see there is K1, K2, and so on and so forth. The text is reversed. The text is reversed because this is actually the silk screen on the back of the PCB. So it depends on where you want it to be visible and not visible. Okay, so this is a matter of preference on how you want your switch orientation, but you do have to remember that the way that your switch will mount. Now I have run it previously just in this orientation, and that's exactly the same way that I'm going to run it now. So we know that, so I'm just going to shift this over here for the moment. So I'm going to have a whole bunch of switches that will be lined up. It's going to be 6, and then there'll be some fractional gaps. There'll be a gap which will be something like that for 7, and then will be 8. Now I'm going to move the whole block over, and then I can keep running each one of these out. And this is a time and a painstaking process because we need to separate out all of our components and lay them out however we need to. Now I have not done a mapping of the switch numbers, but had I done that, then it might also help with all of that. But what I'm going to do is I'm actually going to shift all of that over to the top corner like that, because that way I can work a little bit neater, because I know that that's going to be the boundary of my switches there anyway. Now these ones over here will obviously have to move at some point in time to make sure that they're the correct spacing, but we know that they're kind of going to work because we're going to have this gap space happening down here at some point in time. Now I'm just going to move that off the screen so that I can reference it as I go. Back over to here. I think that's a quarter switch, isn't it? That's the half switch through the middle of the whole footprint like that. So that should be a quarter. Okay, 2, 3, 1. Oops. Okay, see, I almost made a mistake there. Now that one should be 1, 2, 3, 4. Now you can always go back to, of course, your schematic to check as well if you've got it right, because this is where I've done my numbering, so I should be ending up on 21. I'll go back to there. There it is, K21. So we'll keep going, move that down. Now, this is where things get a little bit tricky, because there's the 1U, and then, actually, I'm going to move all of those down again, because I'm running out of space over there. There's the 29, 30, 31, 32, 33, 34, 35. So 35, if I check against that, is that correct? Yes, it ends on 35. We go back to my PCB, and now I have to go and grab 28 U1. Now this is where we need to decide, well, where do I want my orientation for this? Because you can rotate this. We can rotate it that way, or we can rotate it so that it becomes the other way. Now the rotation does kind of matter because your traces will be involved with this. So for the moment, I think I'm going to put it like that. And does that work? So you have to look at that and go, no, that's not going to work. And the reason why it doesn't work is because my column pin clashes. So let's move that back out. Wrong one. There we go. So I'm going to move that one back in. And we're going to rotate this around some more. And then we put that back in. Okay. So does that clash? Does that clash? The switch hole's fine. This one though is that one's also a little bit tight, isn't it? Now of course if we're using this 2U, it shouldn't impact on this one anymore because we're not doing the same one. But for the moment, I think that one should. The problem is this diode is going to contact that one, isn't it? So we'll try and, we're going to have to rotate that around the other way, I think. And we're going to go with the column 1 because they are both a column 1, so it shouldn't matter. I believe that it should be okay. Alright, so we're going to put it that way because it's still a column 1 pin out regardless, and if you're going to be using 2U, then this one's not going to be used, but we won't have any clash with the rows because that row is in relation to this row, whereas that row is in relation to this row. And if they touch, then it's going to be causing some confusion. Okay, so that makes good sense to me. We'll go with it, and we'll find out at the end of the day. There's 36, 37. Nope. Right, so this is the arrow keys now. So this is where it's important to make sure we know what we're checking out. So key 36, go back to my schematic, key 36. Excellent. We're back again, 37, 38, 39, and this should be 41U. 41U, fantastic. Then we've got 41, 42, 43, 44, 1U, 45, 46, and lucky last 47. Now down here you'll see a whole pile of components, and these are our diodes. But before we get to that, let's get our other bits, which are off the screen. Let's move that over. Let's move that over. Let's move that up over there. So this is 42U. Let's rotate this around. Place the 42U on that. Once again, the columns will contact, but that shouldn't be too much of an issue. And then for this one, the 44-2U will live there. And will that contact anything? It looks to be good. Column, 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 which is fine. Diode, 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 diode. So there's no contact there, except the pinholes are a little bit on the loose side. Now, of course, if I change that by rotating it around, will that allow me to have... No, that won't do much better, and you can see the large hole is actually going to be cutting across that pad. So we might as well go back to what we had before. Rotate that, move it back up. The small hole's cutting that one anyway, so that's okay. Maybe, I think. Well, we'll give it enough boundary anyway, so that shouldn't be an issue. Should not be an issue at all. Overlap, touching, touching, and that is in the middle. Now comes the fun part, separating diodes, because it sucks. So diodes, footprint 1, footprint 2, 3, 4. Now the orientation for these is entirely up to you, how you want to do these in regards to front or back. I put them on the back as well, so that they are the same as the key labels, because you'll see right now they are on the front because they're in blue. They're not, the text is not actually reversed. It's much the same in terms of preference, I guess. It's a good way of describing it, but some people are a bit more picky about it than others. Now, if I'm very careful about where I select, I can separate them out easier without having to go through that little sub-menu. This is probably one of the more tedious parts of designing a PCB. I'm not sure if there's an automated process or not, but this is the way that I've done it, had to do it. We'll probably continue until somebody goes, dude, there's a better way of doing this. But in a way, it's a hobby, you know. It's kind of relaxing and passes the time a little bit, kind of, perhaps. Now, remembering that your diodes will be facing with the line, the forward direction, against the square pad as well. And you can see that the rat's nest is already telling you what is going to be connected to what, where. And that's a handy feature, so that you know what you are doing. Now, these white footprints on the MX squares is the actual outside physical boundary of the switch. whereas the yellow internal boundary, I believe, or the white internal boundary, depends on if you're using MX or if you're using ALPS switches, is the actual physical footprint. So this is the gap space for including the cap, and then I think that's the spacing for the actual physical switch. Now that's important because you can actually put components within that white boundary that won't clash, as it's only to handle cap spacing rather than the actual physical switch. Whereas if it's the physical switch, you're not going to be able to see your switch on the PCB because it's in the way. Alright, so these are all done. Fantastic. So I'm going to zoom out. Now, this is the part where you get to be a little bit... Cancel. So I'm going to grab the first 5 and I'm going to move them up there so that I can get them easier. So I'm going to grab that, select them all. Oops. Okay, yes. Right click, and I want to flip them. So now they're all on the backside of the PCB. And then I'm going to grab just that one, and there it goes. Now you can put them underneath or you can put them on the side and everything else like that, but what I might do is I think I'm going to rotate them so that... Can I bulk rotate them? Rotate. Yes. Okay. No, not what I was. Well, it kind of worked, but I might as well just rotate them this way. There we go. Because if I now select this, yeah, there we go, and I do this, doesn't that make life so much easier? Okay, now I've got to go grab 6 and 7. Plonk. Okay, flip, rotate, rotate, move, like that, and move, like that. Now, you would think that would be nice and neat, but the problem that we have now next is where are we going to put our Pro Micro? So this is the Pro Micro, and last time I put it over here in this orientation. This time though, I'm not going to, because it was a real pain to solder, so I want to actually put it over this switch, so it's a little bit more in, it's one switch in, but you'll notice it's now going to clash with my diodes, so it means I have to get creative with my diode positioning so that I won't have that problem. And that's going to affect, of course, both the K6 switch here and the K13 switch. So just going to put that there, but while I'm here, I'll flip this so that it is actually on the back. Flip and rotate, 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 rotate. Doesn't really matter which way I'm rotating it because I still have to do it twice, so that it is now positioned on the back. And this one, which is where the TX is up in this corner there. So instead, I'm going to move this diode, and I'm actually going to put it up the top. So I want to rotate this again, and just trying to think, is that the right rotation? No, the other one was correct. There we go. So I'm going to put it, I can put it up the top or I can put it at the bottom. Let's just put it at the bottom. No, we'll go on the top. And then this one here, I'm going to rotate like, what's a good way of doing this? Like that. Now that one, oh crap. What did I do? Okay. So I'm going to rotate that one. That, and then this one. Nope. Footprint D7. That's the one that I want. And then I'm going to rotate that as well. Oh, it's going to be. There we go. And let's just move it there, just for ease of routing. Now, of course, this is all fun and games until you have to do the routing, the traces later, and this is when you're going to discover whether you did things well or not well. Because it's going to be murder, absolute murder. Now I'm going to zoom in there to see what on earth is happening here. So this is a row 0, so the row 0 pin has to go there, which is fine. And the switch stuff seems to be okay. It seems to be fitting into that edge, so hopefully we're going to be alright. But you know what? Mistakes happen, and if they're not alright, they're not alright. Now, so that took a really long time. The rest of this is going to take just as much time. So what I'm going to do now is I'm actually going to end this part of the video so that I can start putting the rest of these diodes in, and then following on from here we should be able to move into drawing our boundary for the edge cuts, as well as probably the start of the traces and things like that. Now in terms of the layout, the gap space seems to be about right, and all of the keys are in the right position as we had intended and designed accordingly to the diagrammatic that we had sketched. So it looks just like that. Okay, so thank you for checking out part 3, and we'll be right back hopefully with part